Yeah, so my name is Nicolai. I'm working, as Kirill said already, in Bolt as well. And I want to start with disclaimer that we actually in Bolt started using Kubernetes like way earlier, just like backend was quite late. But we were using Kubernetes for different workloads since 2020 at least. Yeah, so basically I'm working as a SRE in Bolt for many years already. And today, this talk will be describing our journey, how we started using Kubernetes to run redises. And our team is quite small subset of the SRE team. And basically, we are responsible for everything stateful except databases. So the work guarantees on reliability is still high, but not as complex as with databases. So basically, we are running redises, Elasticsearch, Kafkas, and we are provisioning SNS SQS for the developers. And our aim is to spend as minimum as possible resources to maintain and provision the new resources for the teams and make it as automated as possible. And yeah, so basically, in the beginning, when I joined Bolt, 2020, I think, we had pretty so-so configuration to running redises. So basically, we were using Ansible to manage everything, including AWS infrastructure and provisioning later. And basically, all the provisioning was just you run Ansible, and then you pray that nothing will happen, and everything will be successfully finished. If some like network error or your laptop will disconnect from the Wi-Fi or whatever API error on AWS side, you may end up with like instances running, but you don't have it in the state because Ansible don't have proper state. And you have to clean this after yourself and run again. There was continuous drift because without the state, all the management of the type of the instances and stuff like that was through clicking in the console, and like some stuff that was in the Ansible was not always the same in the cloud. We had pretty basic Nagio style alerting. Basically, it was just basically either Redis is up or not, and that's it, without like any gradations and other advanced alerting. And we had the bash script, which was running in the cron to make a backups as a kind of last way to restore something. So I started with improving this stuff, and we moved management of AWS infrastructure to the Terraform. So we had always state, which was almost always the same as cloud. We still kept Ansible to provision Redis itself. There is a typo. Yeah, I was provisioning EC2 with Ansible. We created a couple of Python helpers for everyday tasks. So basically, if you have some on-call call in the night, you don't have to remember Redis CLI or some other commands to check like what is happening. So basically, it was helpers to check the status, to do the failovers and stuff like that. And we had the monitoring and alerting with Prometheus and Alert Manager, which with more alerts than before and with more data from the Redis itself. And we created eventually our own Golang daemon to do the backups and upload them to the S3 to keep them for a couple of days to make more resilient. So our backups is, we are not providing the point-in-time recovery. The backups are mostly like a last resort if something is very bad. So because it's usually we are doing all the maintenance with failovers and nothing is lost. Yeah, something like that. So our infrastructure looks like this on this slide. So basically, we have backend services running on the left. Yeah, on the left. We have it's basically usual high availability setup with Sentinels for the redises. We have Sentinels deployed in multiple AZs, and we have EC2 instances with redises running there. We have master and replica set up, and Sentinel monitored them, and failovers if required. And backend is going to the Sentinels and requests what is the IP and port for the Redis for this name, and then service is using that. And this setup is quite reliable. And you may ask a question like, why we just not using the managed Redis like Elastic Cache? So first of all, we wanted this solution to be maintainable. And with Elastic Cache, a lot of stuff is hidden from you. And moreover, the issue for us is that outage, even like for 10 minutes, could cause us like quite a lot of money loss. And with AWS support, you can get a real-time answer, but it's still you have to wait for the response time. So we wanted to have it under our control. Second of all, we wanted it to be cost-effective. So up until Redis 6, the multi-threading was pretty bad in Redis. And no matter how big instance you will provision for the Redis, it will still use only one core. The situation is getting better right now, especially in Elastic Cache with the patches, but still we were managing to run multiple Redises per host, and this way we were utilizing more effectively multi-core instances, especially the big ones. And another reason is the scale. So basically, this slide shows how our amount of Redises grows from the year 2020 till now. Basically, in the beginning, it was around 100-something Redises, and now we have 500 Redises, and this Redis counts master plus replica. So if we count like all the Redis instances, it will be twice more. We have around 1 terabyte memory provided in Redises, and in 2020, and now we have around 5 terabytes. And requests per second, commands per second was around 1 million in that year, and now we're closer to 5 million. So this solution is pretty reliable, but it had some problems, which we realized a couple of years ago. First of all, it was pretty time-consuming to provision the new Redis, because it was all the manual operations, and you have to wait for instances to create, then you have to provision them, then you have to enable monitoring, and the order of steps is pretty crucial. So especially in the night, if you wake up with on-call and you need to do some maintenance, you have to be very awake, otherwise you can like just drop accidentally stuff. And with Redis, you will drop the state as well. And the drop of the state is not very critical in most cases, but it might overload other components like databases. So we are trying to prevent this as much as possible. Yeah, and it's pretty dangerous. As I mentioned, if you mess up like in which steps you are doing stuff, it can lost one or multiple Redises. As I mentioned, we have multiple Redises per host. And all the workflow of the management of the Redises was through Jira. So basically, if developers creating new service, developer had to go to the Jira, create ticket for us. We have to get it from the queue. Then we have to provision it. Any like changes, if developers need more memory or whatever, all through Jira. And it's slow and time consuming. Second topic is a couple of years ago became more relevant. It's cost optimization. Basically, we wanted to provide the same information as Kirill provides from the backend to the teams, how much they're consuming resources from their services. So we started assigning Redises to the proper instances, which are assigned to the teams. We were trying always to keep the CC2 instances optimal to the size. And developers can't control this cost. They just get the report, and then they have to go to Jira again and ask us like if something possible to optimize. And the last one is the updates. The same as everywhere. Basically, we need to keep up with operating system updates, Redis updates, other components updates, and if something is easier to update, something is harder to update. And it also includes quite a lot of manual steps. Like with OS update, you have to reprovision hosts from the scratch. And it's like also specific order of actions. So I think 2 or 3 years ago, we came up with this brainstorm session At that time, I think we had only 3 people in our team. So we got it together and we estimated like what is our ideal solution for the next solution could look like. And this is the photo from that time. You don't have to read it. I will describe it later, but you can see how it was in the beginning at inception. So we had our session when we discussed that, and then we continued with ADR for this solution. Basically, we are using ADR in Bolt for the documenting what architecture changes plan to build. Then we are collecting review, we are collecting approvals, and then we are continuing with the solution creation. So what we wanted to achieve, we wanted to create kind of Redis as a service, deeply integrated with Bolt. So we have a pretty good experience with running stuff in the Kubernetes. We started with running telemetry there on a pretty big scale, and we have had a pretty good experience with that, so we are decided to use Kubernetes as node scheduler. We were using Carpenter from the beginning for the nodes management. We wanted to have automatic provisioning from the code from the beginning, and Kubernetes operator to manage redises. So since we are on AWS, we were using AWS K8s as Kubernetes platform. We are using VPC CNI for the transparent connectivity. So basically from the end user perspective, nothing changes. We had the EC2 with IP addresses, and then now we have pods with IP addresses, and backend can connect to them without issues. And we are using Flux for the GitOps for all our clusters. Speaking of Carpenter, we are pretty happy with Carpenter. It is providing us with nodes provisioning. We are running consolidation there. So basically, if we are adding new redises or if we are changing the resources, Carpenter is always keeping costs optimized with what we are requesting. Without our intervention and without the downtime to the services. So provisioning, it looks right now as a developer. We have this framework Kirill mentioned for the development. Developer adds new Redis usage in the code. After that, when developer opens the pull request to our repo with Redis is automatically created. And we are reviewing that if everything looks correct. And after that, in a couple of minutes, Redis is ready. It's comparing with a couple of hours before, in best case scenario. And we don't have to do anything with that, so we just review pull request. So, operator for the Redis is based on the open source Redis operator, but we needed to patch it to support external sentinels, which I described in a minute. And we also added additional fixes for the issues we hit when we were rolling out our solution. And basically, operator is provisioning redises from the CRD definition, and it keeps this redises always alive, no matter what's happening. Just in case, what is CRD? CRD is custom resource definition, is the mechanism to provide custom types in the Kubernetes API. Operator is using CRD to extend the Kubernetes, and based on the CRD, operator creates stateful sets in our case, and config maps and services to provide the Redis, the stateful set, Redis pods. So how does look provisioning of the new Redis? Basically, on the left, new CRD definition is coming from the Flux when pull request is merged. In this case, the name of this Redis is Redis1. It comes to the operator. Operator is creating the new stateful sets for the redises. When pods are ready from the stateful sets, stateful sets are pods using the config maps for the configuration of Redis. When pods are ready to be registered, operator is going to the outside Sentinel and registering this new redises there. And after that, operator is monitoring in the forever loop if redises are alive and keeping them like running and up and running without issues. So if something is changing in the CRD definition, for example, if we added like more resources or if we added more replicas, just in case, operator is getting this diff from the CRD and it is provisioning new stateful set. And then operator is ensuring that these new changes are provisioned to the pods. So basically, operator is smart enough to understand which of the pods is right now master. So it's always keep this information, and when reprovisioning is required for the stateful set changes, first got killed replica pod, then replica pod is recreated with new resources, and operator is ensures that replication finished and the replica is up and sync. And then failover is happening to the new replica, and then old master got killed. And this way, operator is doing as little as possible actions and always keeping this stuff up and running. So why we patched the operator? So basically, Redis operator configuration by default is not very matching our configuration. Basically, Redis operator by default is provisioning stateful set for the redises and stateful set for the sentinels. So basically, any new redis is provisioning through 3 new sentinels. And in this case, we are wasting resources by creating more pods than we need. The second one, we need to rewrite our backend to understand like to which sentinel it should go for each master, which complicates stuff. And moreover, from our perspective, it also not very good from the reliability perspective, because we are running all this stuff in the same cluster, and there are more chances that sentinel will break somehow, and then Redis will break somehow, and in the end we will get not a live Redis. But by keeping sentinels externally from the K8s, we are ensuring that they are pretty stable. They don't have much load because they are used only during the service discovery time. So our backend right now is going to the same sentinels monitoring the old setup and the new setup in EKS. And the requests are coming from the services to the redises, either way in the old setup or in EKS. So basically nothing changes from the backend perspective. But also we needed to patch operator to fix a couple of issues in the Redis. One of them, which we hit first, is that failover is requested automatically on the Redis pods on the master before the master stop. But due to logic of operator about the same time is trying to fix the difference in the sentinel status. So basically, sentinel detects that there are more replicas than like 1 in our case, and the operator is resetting the sentinel. But sentinel in this case is just stops the failover procedure, and in this case, old master got killed. New replica is not. Oh, fuck. Sorry. Old master got killed. New replica is not promoted to the master, and basically we are getting dead Redis while everything could be way better. So how we fix that? We are checking the Redis pod's age, and we are not sending reset if it's not old enough to avoid this race condition. It's probably not the best fix, but it's working for us. So the second issue was pretty fun with the, and not very clear for us for some time, but luckily we hit it on the pre-live. So basically, EKS VPC CNI has default IP release timeout of 30 seconds. And it means that if you have a big pool of changes, like you are changing, I don't know, 10 redises, which is 20 pods, all of them will restart. And then new redises will start with high probability on the same nodes, and they will get the same IP address. And what happens next is this operator finds this new non-provisioned replica, and it provisions this replica as as a replica of master 1. And from operator perspective, everything should be fine. Operator proceeds with killing old master, but the issue is that there is rest condition when Sentinel also keeps the cache of the older replicas. So basically, old IP is listed in the cache as a replica of master 2. So between operator setting properly new redis as a replica, Sentinel comes and fixes, like in quotes, this by setting replica to the master 2. And after that, operator proceeds with killing old master. And in the end, we are getting complete mess of redises assigned to whatever address they have. Some masters are lost. Some have 3 replicas, and it's very fun to debug. So how we fix that? We, as well, it might be not ideal fix, but it's working for us. We increased IP cooldown period from 30 seconds to higher value, and we set it higher than reset timeout. So basically, we ensure that IP will not be reused up until reset will happen, and reset will fix all the cache issues on the Sentinel side. We have some not very good consequences of that, is that IP address is assigned to the nodes, and it will be not, like nodes have the limit of IP addresses to assign, and if we are reaching that, we have unable to schedule pod because of this timeout. So we need to work on that later. So, and the third issue we had recently is basically that operator decides whether it wants to continue with provisioning based on the readiness probe of the pod. And readiness probe on the replica is checking only for master in sync is equal to 1. And what we found out is that this value in Redis info output is going to the 0 when buffers are overflowed. So basically, Redis reports that master in sync is not happening anymore, but it's happening when it resets the cache and trying to resync again from the master when buffers for the replication are overflown. And because operator have only this check in mind, it continues provisioning when replica is not fully synced. It usually happens on the big redises, like more than 20 gigabytes. And in the end, we have new master completely empty. But from operator perspective, Redis is up and running. It just no data is there. So how we fix that? We are checking also for the master link status. And the master link status is either up and down or down. And when it's up, it means that it's completely synced. So now if replication cannot succeed, operator waits indefinitely with provisioning and don't kill the old master, which is we wanted to achieve. So we discussed like how we want to proceed with our migration plan. And after we did some initial changes to the operator, we created pre-live EKS cluster. And we started migrating existing pre-live redises there just to check how everything works, because we don't have much redises there. And after we decided that pre-live is stable, we proceeded with live EKS creation and deploying everything there. And in our case, new redises are using new solution by default from beginning of this year. But we actually started using it somewhere in the end of the last year, but on the bigger scale, it started using from the beginning of the year. And migration of existing redises is an ongoing process. It's manual, but it looks like this. Basically, we have old setup on the left. In the old setup, we have Redis, like Redis 1 master replica, Redis 2 master replica, and so on. In the new setup, we have EKS cluster with operator and replicas. So basically, operator have a bootstrap mode when you set in the configuration of CRD that this Redis will be bootstrapped from that existing Redis. So operator creates new 2 new replicas. So basically, replica 1 is in old setup, and 2 new replicas are in the new setup. After everything synced and looks correct, we are doing failover. And after that, removing the redises from the old setup. So basically, after that, this redis 1 is in the new setup, and the other redises are still in the old setup. And we have to repeat this one by one, but eventually we will get rid of the old setup, I hope. So this is how looks migration graph, which I collected. So basically, we don't get much decrease in the existing redises which are on the top, but luckily we have like almost half of the redises already running in the new setup. So basically it means that during this year we spent way less time creating new redises, and all of them were provisioned from the automation and with minimum intervention from our side. So from the problems I mentioned in the beginning, we right now have provisioning flow is fully automated. Developers actually automatically getting requests to review resources they are requesting for the redises. It's not always possible to estimate what memory limits are there, but eventually they will get reports about how many their services are consuming money. So now they have incentives to improve that. Reconciliation and provisioning is fully handled by EKS and operator. So redises are always up and running. And we had a couple of outages when some AZ had issues in AWS, and operator was completely handling this without our intervention. So we actually lowered alerts, so we are not waking up in the night when this happens. So we have alerts only if everything is very bad when master is disappearing. And we have some simple Python helpers to simplify pretty rare manual tasks, just to check what is running on the node and what are the status, and to drain node from redises. Redises right now, in terms of the costs, are automatically assigned to the proper nodes. So basically we have some kind of vertical names, and redis from the code itself, when new redis CRD is generated, it automatically have information from which part of the bolt this redis is coming, and this redis will be assigned automatically to the proper nodes. So from SRE perspective, we don't have to do anything, and if something changes, it automatically, when we merge the pull request, new redis will be launched on the new node pools, and failover will be happening, and we will do nothing about that. And Carpenter, thanks to the consolidation, have keeping the costs optimal always. So if we are adding more resources, it's optimizing the nodes. Or if we are removing something, it is decreasing amount of nodes without our intervention as well. And developers have full control over the costs. So basically, they can tune and create pull requests for us with lowered or increased resources. And we will review that, and after that, everything will be released. And EKS version update happens a couple of months, and it takes for the control plane around 10 minutes. And we never had issues with that. Operating system updates is happening automatically with new EKS AMIs, and when we are updating EKS itself, we are reprovisioning nodes with the new AMI. So we don't have issues with old Ubuntu's or something like that we need to reprovision. And the Redis update itself and other components are just happening by setting the new image version in the CRD, and eventually we are rolling out this completely, and that's basically it. We don't have to run Ansible or something to provision that. So from the future plans, we plan to continue migration. We want to achieve majority of the stuff running, except some corner cases in the old setup. We plan to continue improving this solution based on our experience, and we want to estimate if we want to contribute or release operator fork, because operator itself is not very actively developed right now. So I'm not sure if we will be able to contribute. So as a conclusion, I would say that stateful workloads on Kubernetes are working from our perspective, especially like if it's not databases, when guarantees are less critical and stability and stuff. Operators, I would say, pretty required for that to do all the monitoring and the reconciliation. It is possible to create your own small SaaS with a pretty small team, but issues could be hard to debug because it's everything dynamic. You have to check like a lot of logs eventually to check what is happening and why it's that, as I described in the issues we found. So feel free to ask me any questions now or after the presentation. Thank you.
Thank you.
Right, thank you for the presentation. Interesting. Small question to understand. You had for a backup previously used Bash, right? And then made the decision to switch to write application in Golang.
Yeah.
Yeah, why?
So basically, the idea is that historically, our redises, at least majority of them or some of them, are high-loaded, and we cannot leave this BGSafe default configuration when BGSafe is doing automatically when some amount of keys is changed. So in the past, we had this script in the Bash, which was just running every like 5 minutes, and it was doing this round-robin selection of selecting all these redis to make a BGSafe, and it's executing BGSafe. So basically, every redis was backed up every 5 minutes or so. But eventually, we had this issue that we have only one backup, like from the 10 minutes ago, and that's it. So like if something happened before that, and also this Bash script was kind of like pretty basic. So we eventually rewrote this into the Golang application. It's not very complicated, and it's like because we are not like programmers, very like huge. So it was kind of okay-ish for us. And it was basically doing the same. It was checking age of the last backup. It was running BGSafe. It was checking that BGSafe finished. Then it was getting this file from the file system and uploading to the S3. And then in case of outage, we have ability to download the BGSafe dump and restart Redis from the backup. So basically, we wanted to have more options to restore from, just like the last backup. And we don't need this point-in-time recovery, so like every 15 minutes or so is enough. And we actually haven't had much issues with the maintenance, so I think we didn't have any requirements to restore Redis from the backup, but backup itself is pretty useful when some usage patterns are changing and developers cannot understand like what is happening, and we are helping them with restoring the backups in our additional host and checking like what is the change difference in the case. So basically, what changed like from 2 days ago. It's kind of useful.
A simple question.
Yeah.
You mentioned Redis 5 and 6. The versions, it's multi-threading was better in
version what?
Version 6. 6.
Yeah.
Yeah. But have you considered any alternatives to Redis itself?
Yep.
Because of the license change?
I think we are not affected by the license change because we are not providing this externally. But recently we had a task with vector database deployment in Bolt, and it's pretty big. And we are deploying it so far with Redis search plugin. And we also evaluated Dragonfly as an option for that because Dragonfly is kind of multi-threading alternative to the Redis. But so far we decided that there is no much advantages comparing with default Redis, and also compatibility is not very great. But we have plans to investigate KDB, which is right now owned by Snapchat. And we like this option in KDB that it's fully multi-threading, so it will fully utilize all the cores. And also we like the idea that it's able to offload less used data to internal SSD. So we want to investigate it to improve our performance and also to cut costs because the local SSD on EC2 are basically almost free comparing with memory.
I want to ask, how does the external Sentinel reach out to the internal pod IP? Or how do you address the replica inside the EKS cluster?
Yeah, basically we are using VPC CNI in EKS, and it provides you all the pods in the EKS have real IP addresses in your VPC. So basically, there is like you just allow connection on security group level, and everything works as a clearly, transparently. So you don't have to do anything. Yeah, pod IP changes. That's how basically when new pod is launching, operator is provisioning it as a new replica. Then it's doing failover. Failover is happening, and every time IP is updating on the Sentinel side. So Sentinel always knows what is the master IP.
So the operator updates the Sentinels with the new IP, basically.
Operator updates new pod. So basically, new replica starts. Operator sets it as a replica of existing master. Sentinel remembers about this master and replica. Then failovers happens. Sentinel knows about new master. So basically, Sentinel always knows what is the master IP, because Sentinel is monitoring all the pods, all the replicas of this master. It's basically the same as in old times, but in the old times you have static IP addresses for the static EC2 instances, but in this case it's just like instances are changing always.
Okay, I have a nice question. Pets versus cattle. When you think about Redis as a piece of software, is it like a pet for you, or you approach it less?
I would say it's a cattle, but you need to feed it first. So basically, you need to grow it so it will sync data, and then you can kill it.
Okay, thank you. On that note, let's have a round of applause for Nicolai.
Thank you.